The ability to calculate determinants is an essential computational tool in linear algebra. In high school they taught you that the determinant of a 2x2 matrix, which can also be expressed like this, is simply A times D minus C times B. And while that is true for a 2x2 matrix, you inevitably start to run into some problems once you start working with higher dimensional vector spaces. For instance, what if you had a 3x3 matrix and you were asked to compute the determinant? Luckily there's a formula for that. And while at first it might look intimidating, it's actually quite simple once you start breaking it down into steps. I choose to see it as an instruction on how to write the mathematical expression for a determinant. The first thing to note is that the expression is a sum, which means whatever comes after this Greek letter sigma here is just some term you need to repeat. The letter n here on top just indicates how many terms we have in our sum, and it corresponds with the number of rows we have in our matrix. You might know that only square matrices have determinants, that is, matrices with the same number of rows as columns. In our case here, our matrix has 3 rows and 3 columns, so n would be 3. The letter J here is sort of an indication of where to start. In this case it's telling us that every time it says J in our first term, we write 1 instead, and so forth, with J being 2 in the second term and J being 3 in the third term. Now let's have a look at what the factors actually mean. This first factor just determines whether we're going to have a plus or a minus in front of our first term. And since we are in the first term, we'll substitute J for 1. That'll give us minus 1 to the power of 2, which of course is just 1. You'll find that the terms will conjugate between having this factor be 1 and having it be minus 1, which effectively writes a plus or a minus in front of the whole term. This next factor asks us for one of the entries in our matrix. We will again substitute J for 1, and you'll see that it asks for whatever entry is in the first row and the first column, as indicated by the 1, 1. That in our case would be the entry A. Now this last factor here is itself a determinant. Once again we'll substitute J for 1, and you'll see that we're asked to find the determinant of the matrix A1, 1. And what that is simply the matrix A without the first row or the first column. That gives you a new 2x2 matrix with the entries E, F, H, I. This is great, because we already know how to compute determinants of 2x2 matrices. And that's it. That's our complete first term. And now we just have to do the exact same steps for the second one as well. And of course this time, whenever it says J, we just write 2 instead. So it'll be minus 1 to the power of 3, which is minus 1. We're asked to find the entry 1, 2, which in our case is B. And lastly, the determinant of whichever matrix you get from taking the matrix A and deleting the first row, and now, since we're in the second term, the second column. Wasn't that easy? Now we'll just repeat the same exact steps for a third and final time. And there we have it, a complete mathematical expression for the determinant of the matrix A. This is an extremely useful tool to have, and it works not only in 3 dimensions, but in 4, 5, and whatever dimension you want to work with. I do have to say though, that it gets increasingly more complex the higher up you go. Here's an example of what it looks like for a 4x4 matrix. And now we obviously have 4 terms, each with their own 3x3 matrix, that has to be computed just like the example we just went through. You can imagine how long it'd take you to do a 4x4 determinant, but it would work nonetheless. I hope this video was helpful, and that you now have a better idea of how to find determinants. Leave a comment down below if I wasn't clear about something. I promise I'll get back to you. But other than that, thanks for watching, like the video and subscribe to the channel if you wish to see more free educational stuff like this.